what might occur if another 6-mile-wide asteroid, traveling at the same speed as the dinosaur-killing impactor, collided with Earth today and explores whether humanity could survive. 66 million years ago, the dinosaurian downfall. 66 million years in the past, dinosaurs still dominated Earth in staggering variety. Towering sauropods roamed vast floodplains. Gargantuan predators like Tyrannosaurus rex terrorized smaller creatures, and swift raptors patrolled lush forests. For over 160 million years, they ruled the ancient continents in an ecological harmony only they understood. However, the planet's cosmic fate held a ruthless surprise. An asteroid, roughly the size of a mountain, barreled in from the asteroid belt between Mars and Jupiter, heading straight for our unsuspecting world. When it hit, this colossal space rock carved out a massive crater, about 115 miles in diameter and 12 miles deep. The explosion released as much energy as 2 million Tsar Bomba-scale nuclear devices, going off simultaneously, enough force to obliterate the vast majority of life. Known as the Chicxulub impact, this event exterminated the dinosaurs and roughly 75% of all species almost overnight, resetting the stage for mammals to eventually evolve into us. Scientists suggest that had the asteroid landed elsewhere, perhaps in a part of Earth's crust containing fewer hydrocarbons or sulfur-rich rocks, life might have persisted differently. However, it struck near the Yucatan Peninsula in Mexico, unleashing chemical reactions that plunged Earth into darkness, triggered monstrous tsunamis, and ignited planet-wide wildfires. But what if that scenario repeated itself today, with a similar asteroid hitting precisely the same spot at roughly the same 45,000 km speed? Could our modern civilization somehow avert utter catastrophe with advanced space technology, global coordination, and bunkers? Or would humanity be doomed to suffer the same fate as the dinosaurs? Let's piece together this hypothetical doomsday from our knowledge of the original asteroid and our present capabilities. Now, how big was Chicxulub? The dinosaur-killing asteroid measured an estimated 6.5 miles, 10 kilometers in diameter, traveling at an astonishing 45,000 miles per hour, 20 km/h, upon atmospheric entry. That speed alone delivered a staggering wallop, roughly 100 teratons of TNT in raw kinetic energy. Once it slammed into Earth, the raw impact energy vaporized rock, sent superheated winds across continents, and choked the atmosphere with ash and sulfur. The outcome, mass extinction and the end of an era. Scientists point out that it arrived at the worst possible location, unleashing chemical havoc that spelled doom for large swaths of life. Napur, modern implications. Could we detect another Chicxulub? You might think telescopes would see a 6-mile-wide asteroid from millions of miles out. However, astronomers warn that the thousands of kinds of dangerous objects remain only partially tracked. Some large, city-ending, or species-ending asteroids lurk on unknown orbits around the Sun, masked by their dark, light-absorbing surfaces. Even more alarming, near-solar approaches can blind us. If an asteroid comes from the direction of the Sun, it's extremely difficult for existing telescopes to spot until it's too late. Interstellar visitors like Oumuamua, spotted only after whizzing past the Sun, highlight our vulnerabilities. That object was much smaller, about 400 feet, and posed no known threat, but it demonstrated how easily an uncharted mass could slip by. If we had only a few months' notice of something Chicxulub-sized heading our way, it might be nearly impossible to mount a successful deflection. The Doomsday Prelude. A new asteroid approaches. Let's imagine a scenario. Observatories suddenly register a black speck crossing the solar disk, growing larger with each passing hour. After frantic calculations, astronomers realize it's a 165-mile-wide asteroid, inbound at 45,000 miles, about 90 million miles away, leaving us 83 days until impact. Governments, fearing chaos, try to suppress the news, but amateurs confirm the data, and word spreads globally within days. Panic ignites. Politicians convene emergency summits. Scientists recall proposed gravity tractor missions, like NASA's DART concept or nuclear strike plans. Yet time is severely limited. The rock's mass dwarfs any prior test object. Even if we launch nuclear warheads at it, there's a real risk of fracturing it into multiple large fragments, each capable of devastating Earth. Without enough time to carefully plan a deflection mission or slowly nudge its orbit, the grim conclusion emerges. The best we might do is brace for disaster. Public reaction, fear, and collapse. Within mere weeks, news outlets bombard the population with horrifying details. Asteroid to strike in 83 days, no guaranteed defense. Social media inflames the situation. Families worldwide rush to hoard supplies, canned goods, bottled water, batteries. Rumors spread of clandestine bunkers for the elite, while highways clog with people fleeing the projected impact zone, perhaps near the Yucatan, reminiscent of the original Chicxulub crater. Government officials plead for calm, but many regions spiral into chaos as supply lines break down and violence erupts over resources. High-ranking leaders relocate to deep command centers like Cheyenne Mountain. In the U.S., originally designed to withstand nuclear blasts, private tech moguls retreat to personal shelters carved into remote mountains. Meanwhile, everyday citizens scramble for any underground refuge, subway tunnels, mine shafts, perhaps even natural caverns, anything that could shield them from the cataclysmic blow. The final hours, the asteroid's fiery descent. As the countdown nears zero, the object fills the sky with a blazing glow, visible even at midday. Military radars track its approach, but they can do little but watch. Communication satellites fail or go offline. Earth's population braces for the unknown. Then it happens. The asteroid rips into the atmosphere at 12.5 miles per second, generating massive friction that superheats its surface. A scorching air blast precedes the main impact, shattering windows and flattening forests in a radial pattern thousands of miles wide. Sonic booms echo around the world. Within seconds, the asteroid slams into Earth's crust, releasing an energy equivalent to millions of 50-megaton bombs. Earth's crust warps, cracks, and heaves, producing earthquakes measured at magnitude 11 or beyond on the Richter scale, far surpassing any quake in recorded history. Tsunamis up to 3 miles high. Blast coastal areas near the impact, while 1 mile high, waves surge across entire oceans. The impact's wrath and immediate aftermath. A towering plume of molten rock and vapor, some of it at temperatures exceeding the sun's surface, shoots skyward. Superheated winds traveling at x-100 plumb incinerate regions within hundreds or even thousands of miles. The atmosphere becomes saturated with ash and sulfur, creating a nuclear winter effect that plunges Earth into near-total darkness. Photosynthesis halts, forests burn, farmland withers, and the planet's ecosystems buckle under the sudden cold. As dust and ash swirl through the skies, the planet's temperature fluctuates, initially plummeting due to blocked sunlight, then rebounding when greenhouse gases spike from worldwide fires. Massive acid rain further poisons waterways, culminating in a global mass extinction event that eliminates countless species. Any humans exposed to the initial blasts likely perish instantly. Survivors might envy those who died quickly, as the new world outside is a hellscape of scorched earth, swirling ash, and unstoppable storms. Dr. Fur. Surviving underground. For those who manage to retreat deep underground, whether in professional bunkers or improvised shelters, the real struggle begins. The land above is ravaged, supply lines are destroyed, and soil becomes toxic. In the first few weeks, the biggest threats are 1. Food and water shortages. Only what was stored below remains viable. Water purification systems may fail if not carefully managed. 2. Medical emergencies. Injuries from the panicked exodus or quake aftershocks need attending. People with chronic illnesses might find medicine in short supply. 3. Psychological stress. Without daylight or normal routines, cabin fever and despair set in. Fear of what's left above can intensify mental health problems. 4. Broken communication. Nearly all electronic infrastructure, internet, cell towers, satellite links, lies in ruins. People huddle around battery-powered radios, hoping for official broadcasts that never come. As weeks turn to months, survivors must decide when, if ever, it's safe to emerge. The ash-laden atmosphere can block out the sun for a year or more, causing impact winter. Surface temperatures fall drastically, while the ozone layer is severely compromised, letting in harmful radiation whenever sunlight does break through. Not a post-apocalyptic landscape. Eventually, the dust starts to settle. Perhaps a year on, small expedition teams from underground communities venture outside. They find entire metropolises in rubble, skyscrapers twisted by shock waves, highways snapped like brittle sticks, and forests reduced to charred stumps. Coastal cities lie submerged under thick mud or swept away by tsunamis. The air remains chilly, laced with acid drizzle from chemical-laden clouds. Rivers might be choked with debris, diminishing freshwater sources. Few animal species survive, mostly those able to endure cold, darkness, or a drastically altered food web. Many marine creatures die en masse from turbidity and chemical changes. Farmlands are blanketed with ash, making them unusable for years. Survivors must rely on whatever hydroponic or indoor farming systems they can jury-rig with leftover technology. The power grid above ground is obliterated, so generating electricity relies on portable generators, stored fuel, or perhaps geothermal sources if accessible. Over time, micro-communities might re-establish small trade networks. Skills such as engineering, agriculture, and medical knowledge are in high demand, along with practical crafts like carpentry and blacksmithing. Scavenging trips become routine, sifting through city ruins for salvageable metal, machines, or seeds. Yet each sortie risks exposure to lingering fallout or structural collapses. Dinosaur, humanity's fortitude and the glimmer of rebirth. Despite the unprecedented horror, human resilience shines in adversity. Some bunkers blossom into self-sufficient settlements, with vertical farms powered by solar or wind turbines, assuming any turbines remain intact or can be reconstructed. Many survivors vow never to be caught unprepared by cosmic threats again, pooling resources into scientific efforts to track future space rocks. Others focus on rebuilding civilized life, forging new social structures, laws, and communities. It could take decades or centuries before Earth's biosphere recovers to a semblance of its former glory. The climate may remain erratic, with mutated plant species taking root in ashy soil. Over generations, humanity might adapt physically and culturally to a cooler, gloomier planet. Archaeologists, in future centuries, might excavate the skeletal remains of cityscapes and wonder about the great civilization that once soared into space, but was nearly undone by a single cosmic bullet. Lessons from a doomsday. While mercifully hypothetical, this scenario underscores the precariousness of life on Earth. It challenges us to consider how little time we might have if a planet-killer asteroid is discovered on a collision course. The knowledge gleaned from Chicxulub suggests it takes just one well-placed impact to unravel millions of years of evolution. In some ways, we stand better prepared than any species in history, wielding advanced technology and scientific knowledge that might, in the best case, detect and redirect a threatening object. Yet the lurking truth remains. With insufficient warning, humanity could be caught as off guard as the dinosaurs. Moreover, cosmic coincidences happen. Asteroids often come from hidden angles or stay undetected until they're dangerously close. Nevertheless, the resilience and creativity of humanity should not be dismissed. If there's enough time and global cooperation, imaginative solutions, ranging from nuclear deflection to large-scale space tug missions, might avert catastrophe. The will to live, innovate, and protect our shared world could unify nations like never before. So we pose the question to you. Could humanity truly survive another Chicxulub-scale asteroid strike if it arrived in just a few months? What strategies would you support? Massive bunkers, nuclear redirection, off-planet evacuation ships, or something else entirely? We look forward to hearing your thoughts in the comments. Remember to stay curious, keep learning, and hope we never have to put these doomsday scenarios to the test. If you found this expanded vision both sobering and fascinating, stay tuned for more deep dives into cosmic threats and the resilience of life on Earth. After all, the dinosaurs' misfortune might be our greatest warning.